Good morning, everybody. Thank you very much for joining us again this morning. We'll be taking you guys through the ETLV and BAT14 series today. So this is one of our new models of product brought into the country. This is our energy storage three-phase low voltage inverter, as well as the 14.3 kilowatt hour battery solution that we currently have. So like a lot of the previous webinars and videos that we've done, please feel free to ask some questions. We can have a bit of an engagement afterwards. I'll go through my presentation. Thereafter, we'll go through the questions and answer everything that we need to answer. All right, so let's get started. So this is the ETLV. Like I mentioned earlier, the ET stands for energy storage three-phase, and then low voltage for the battery connections. We've got a wide variety of this inverter type, from a 6 kilowatt all the way up to 20. In the region that we currently are in, we focus more on the three bigger units, which is a 12 kilowatt, a 15 kilowatt, and a 20 kilowatt unit. Some of the key features or functions we'll go through a bit today as we go through the presentation. One of the main ones being the 200% PV oversizing, or usable PV that we can have through the system. I will get through that and explain that shortly. We'll also go through the parallel solution, how we parallel the system, how to configure the system when we do it in parallel, and what we need to look out for when doing it that way. Next is CT directly connected. So if we look at CT directly connected, this means that we do not need a physical external energy meter or smart meter. The energy meter is built into the inverter. So we get all of our voltage reference through the energy meter inside the inverter, and we connect a CT or three CTs to the inverter directly, and that is where we get our current readings from. So we don't need to physically install a energy meter externally. We install only CTs, or clamp on the CTs that come included with the inverter. Next feature, we'll touch on all of these as we go through, but the next feature is the 150% unbalanced output, meaning that in off-grid operation or in backup mode, we can have an unbalanced output between the three phases of up to 150%. So what this means is if we have got a 15 kilowatt inverter, for example, it's 5 kilowatts per phase if we break it down. Because we can do up to 150% unbalanced when in off-grid or backup mode, we can have 7.5 kilowatts on phase 1. We can have 5 kilowatts in phase 2, 2.5 kilowatts in phase 3, and the system will be able to operate perfectly fine. So we can unbalance the outputs. It's extremely difficult at sizes, installations or sites of this size to have only three-phase loads generally. So we can balance our single-phase loads. It's very difficult, obviously, to always be completely conscious and mindful of how much load we're putting on each phase. I know if I live in a house, I know if I had to live in a house with three-phase power, I wouldn't be too concerned or too worried about which phase I'm putting power on every time I turn something on in the house. So having a completely balanced system is near impossible. That's why we've got the unbalanced output. Next is 3-in-1 dedicated generator port, and we'll touch on that as we go through, and how we can use that dedicated generator port for three different things. 1 for generator in, 2 for AC output 2, and 3 for microgrid solution. This is the appearance of the inverter. So very similar and straightforward to what most of our inverters now look like in the field. There's a bottom cover. We'll show you in the next few slides in one of the installation unboxing videos. There's a bottom cover that we pull off where we do put all the connections. There is a heat sink at the back of the inverter, as well as some smart cooling or smart fan cooling. So part of Solar Academy and the training center that we have with GoodWe is all of the installation unboxing videos, parallel connection videos, getting to know the products, getting to learn how to use the products and all of that. I'm going to now show you one of the videos that we've got. This is through the Solar Academy channel on YouTube. Please do check them out, have a look and see as well if you need any information. We do have all of this information in our user manual. So everything that you do need to find will be in the user manual on our website. However, we have made it a bit easier for everybody by using the YouTube channel. We obviously then can get everything quite quick and in sort of nugget form. It's easier to comprehend, easier to understand, and a lot quicker to do on the go as well. So I'm going to play the video and then we will continue after that.
Welcome to GoodWe training series. Today we will take you through the ETLV unboxing and installation. Unboxing. Here is the ETLV series box. In the box, there is a mounting plate, an accessory pack, documents, lead-acid battery temperature sensor cable, 2 BMS communication cables. Here are the components included in the accessory pack. Introduction of the inverter. Take a look at the appearance of ETLV from different views. Length is 551 millimeters. Depth is 258 millimeters and the height is 756 millimeters. Bottom views of the ETLV. There are many ports for different functions. Installation of the inverter. First we take out the mounting plate. Before installation, first unscrew the bottom screws. Drill the holes using a 8 mm diameter percussion drill, ensuring a depth of approximately 80 mm. Use expansion bolts to attach the mounting bracket to the wall. Fix all 4 screws as shown in the video. Then hang the inverter on the mounting plate. Open the cover on the front of the inverter. Prepare DC cables and make terminals. Plug the PV connectors into the DC input terminals. Prepare 2 battery wires and make terminals. Pass the cable through the bottom of the inverter. Connect the cable to the port and tighten the screws. Next, we will proceed with the AC side wiring. Prepare 5 cables and press the terminals. Pass the cable through the bottom of the inverter and secure it in place. Next, we connect the network cable. Take out the CT cable from the accessories. Take out the 6-pin terminal. Install the terminal on the CT side. Then install the terminals on the inverter side. Finally, put the cover back on and tighten the screws. We installed the Wi-Fi LAN module on the inverter. Turn on the switch. The inverter is now functioning normally. First open the app. Select the corresponding signal for connecting the inverter with Bluetooth. Enter the password 1111. You will be prompted to change your password after logging in. Reset your login password. Click Settings. Click Quick Settings. Enter the password 1111. Click Settings Mode. Set safety code based on actual conditions. Next we select the battery model. Select the corresponding battery model for connection. Next, select the operating mode. Click Start for system self-test. quick setting is complete. Thank you for watching. For more installation and configuration videos of GoodWe training series, please visit our GoodWe community and stay tuned to our official account.
So that is the installation and unboxing video of the ETLV series. They show you absolutely everything you need to know for a basic installation, some troubleshooting. Obviously, we would go through the user manual for. However, everything else is in that video, relatively straightforward, quick and easy to understand, and gives you a good idea of how we can go forward with the installation before you even get to site. So next we'll go through some of the key features for the ETLV series. As we go through these, we'll obviously see some of the slide pieces in red, so the pieces that I'll discuss. So with the ETLV, like I mentioned, we've got from 6 kilowatts all the way up to 20 kilowatts. Most importantly, we'll focus on the 12, 15, and 20 kilowatt units. The 12 kilowatt unit has got one battery input. The 15 and 20 kilowatt units have got two independent battery inputs. So those two independent battery inputs allow us to add on two completely different battery banks together and let them operate completely independently as well. So what that means is we can put 20 kilowatt hours of our Lynx AG3 battery, which is a 5 kilowatt hour battery, on input 1, and we can put 5 kilowatt hours of a BYD battery on the second battery input and have them operate completely independently from one another. We can have old batteries on one input, we can have new batteries on the other input, so it does help for expandability at a later stage. Next is the 200% usable energy input power from a PV oversizing perspective. I've got a slide that I'll show you in the next slide about this. Next, if we look at the MPPT operating voltage from a sales point of view, this is where we can find some extreme benefits with regards to how our MPPTs operate. So MPPT operating voltage is from 150 volts up to 850 volts with max input of 1000 volts. Our nominal is 620. So at 150 volts, probably not going to be running many loads or any loads at that point of view. However, we get 10 or 15 minutes extra in the morning of PV power, 5 minutes in the morning, 10 minutes in the afternoon, whatever it is. But it's that additional PV power that we get to generate. Like I said, it's probably not going to run your loads, but it will charge your batteries during those times. So it allows your batteries to float for a bit longer, start charging a bit earlier. And if we take, let's call it 10 minutes at a maximum over a 5-year span that the inverter is under warranty, or 10-year span that the inverter is under warranty, or when doing a proposal, 10 years, 10 minutes extra every single day, it gives you a much higher PV generation outlook if you look at it overall over the duration or lifetime of the system. So as a sales perspective, it makes a massive difference. From an installation perspective, it could mean you could string your system at one less panel. Obviously, you don't want to go too low. However, if we get as close to that 620 volts as a nominal input, it will be perfect. The MPPTs on the ETLV series are also all independently controlled. So on the 12 kilowatt units, we have 3 MPPTs with 1 string each, with 1 input each, and the 15 and 20 kilowatt units, 4 MPPTs with 1 string each. So every single connection, MPPT string or PV string is independently monitored and controlled on the system, meaning you can have 4 different string lengths, 4 different roof orientations, 4 different angles or tilt angles. The system can operate all 4 of them independently. Here is a quick look at what I was talking about with regards to the 200% PV oversizing. So if you look on the right-hand side of the slide, you'll see the GoodWe inverter. So that is our ETLV with the BAT14 inverter. There's our 15 kilowatt inverter as a demonstration. There's 30 kilowatts of PV connected to it. But at the same time, we can run 15 kilowatts to our loads and charge our batteries at 15 kilowatts. How it does this is built into the inverter. Inside the inverter, we've got a DC-DC controller as well as a DC-AC converter. So we run DC-DC directly to our batteries, and at the same time, DC-AC convert straight into our loads. Generally, when we look at a system, we have to take into consideration loss of efficiency, degradation over time of the panels, bad weather conditions, and that kind of thing. So we overpanel or we increase our DC capacity on the system. By doing that, there are limitations to some inverters, and those limitations don't allow you to get your full production out of the entire PV allocation that you've put on the system. With our inverter, we can use everything that we get. The batteries need to be charged and the loads are very high. We can do both at the same time and actually utilize our entire system. Next is the AC output data. So this is on the backup side. So on the backup side, we can constantly output up to 110%, meaning on the 15 kilowatt unit, we can do up to 16.5 kilowatts. And then at the same time, we can run up to 200% overloading for up to 10 seconds, which means we can handle up to 30 kilowatts of load for 10 seconds on the 15 kilowatt unit, 40 kilowatts on the 20 kilowatt unit. And by doing that, or how we do that, is through the DC capacitor bus built into the inverter itself. So we don't do this through the batteries. We don't obviously do it directly through the PV. If there's enough PV available, it will supply as much of the load as possible. If there's battery available, we supply towards the loads, but it will never pull more than the BMS allows on the inverter, on the battery, and will never use more than we have to from both of those. If there is any big startup or big load or anything that starts up for a short amount of time, to 10 seconds, we can handle that for double the amount of PV inverter capacity. Next, we'll look at some of the efficiencies and protections. You'll notice we have got PV string current monitoring built in, installation resistance detecting. So if we've got any bad earthing or shears to your cable or anything, the inverter will be able to pick that up. Reverse polarity protection, as well as all of your AC overcurrents, short circuit currents, over voltage protections built into the inverter or within regulation and built to code for the NRS and SANS regulations in South Africa. We go to the general data. So the general data on the system, or for the ETLV series, you'll see there is smart fan cooling. So there's built-in fans on the inverter. These built-in fans do not run permanently. They only run when the inverter reaches a certain temperature. So when the temperature, the internal side of the inverter gets too hot, the heatsink obviously will do as best as it can. Thereafter, the smart fan cooling will kick in and we'll be able to cool that inverter down and keep it running. There is an LCD on the front of the inverter, making it easier for configuration on site, as well as a Wi-Fi LAN, a Wi-Fi Bluetooth LAN kit, Wi-Fi LAN kit 2.0, communication dongle that you get in the box with the inverter. We use that to connect the inverter to the network. We also use that for Bluetooth configuration by SolarGo, as well as a LAN port if we need to connect the inverter via LAN to the network instead of Wi-Fi. This is an IP66 rated inverter as well, meaning we can install it in outdoor scenario. With regards to the communication protocols that we've got, obviously I've got Modbus MTU, as well as Modbus TCP IP. So Modbus TCP IP is something that generally we would use for something like Dread or something like that. We've seen it on quite a lot of smart homes nowadays. It's becoming more and more popular. We've got Modbus registers for all of our inverters that are readily available and open on our website. So should you want to integrate any of your systems into a smart home, we have got the facilities in order to do that. Next, we'll jump into the parallel connections for the system. So with regards to parallel connections or parallel system configurations, it is relatively straightforward. We have tried to simplify this as best as possible for all of our installers. So on the ETLV, we've made it even more simple. I'm going to play a bit of the video now from the Solar Academy team showing you the connection for parallel.
Welcome to GoodWe training series. Today we will take you through the installation and configuration of parallel inverter system of ETLV. We are demonstrating parallel operation of ETLV with different power ratings. The matched battery is the Lynx AG3 14.3 kWh. Installation of the inverter. These are two inverters that have already been mounted. First, we will remove the front cover plates of the inverter one by one. Prepare the cables and assemble two sets of DC terminal assemblies. Connect the positive and negative terminals of a set of DC cables to the master inverter. Next, make the AC power cable. Secure to L1, L2, L3, and N respectively. Also connect the AC cable from the slave inverter side. Parallel operation of the inverter. Prepare a communication cable. Unscrew the plug at the bottom of the inverter. As shown in the video, install the plug on the communication cable. Finally, connect the cables to the inverter. Connect the other end of the cable to the slave inverter. We need to use an electric meter. Connect both ends of the RS485 cable to the terminals. Connect one terminal to the master inverter. The other side connects to the electricity meter. Connect the cables from the 3 CTs to the corresponding terminals on the electricity meter. Finally, power the electricity meter through the distribution box. Prepare battery cables and make terminals. Connect the master and slave inverter to their respective batteries. Do not forget the ground wires for the two batteries. Prepare another communication cable. Connect the inverter to the battery for communication. Next, we will establish communication links between the batteries. Connect the communication module to the master and slave inverter respectively. Turn on the switches for the inverter and battery. The parallel connection of the ETLV is now complete. If multiple inverters are connected in parallel, it is recommended to use a combiner box. After connecting the battery cables to the inverter, connect the other end to the combiner box. The slave inverter is also connected to the combiner box. Prepare and assemble 4 cables for connecting the battery. Connect one end of the cable to the positive and negative terminals of the battery, and the other end to the combiner box. The battery match to the slave inverter is connected in the same manner. After the master and slave inverter are connected in parallel, connect the master inverter to the combiner box using another communication cable. The next step is to establish a communication link between the two batteries. Connect the main battery to the combiner box for communication. LCD screen settings. Click the settings button in the upper right corner. Click parallel system settings. Designate one of the inverters as the master unit. The other inverter is designated as the slave unit. First, open the app. Select the corresponding signal for connecting the inverter with Bluetooth. Enter the password 1111. You will be prompted to change your password after logging in. Reset your login password. Click Settings. Click Quick Settings. Enter the password 1111. Click Settings Mode. Set safety code based on actual conditions. Next, we select the battery model. Select the corresponding battery model for connection. Next, select the operating mode. Click Start for system self-test. Quick setting is complete. Back to the main screen. Click Settings. Click Parallel System Settings. Configure the master and slave inverter. Thank you for watching. For more installation and configuration videos of GoodWe training series, please visit our GoodWe community and stay tuned to our official account.
So that is the parallel solution, or how we do parallel on the inverters on the ETLV series. In the user manual, you'll see there's quite a nice diagram that shows you exactly how everything should be wired, how we can wire everything, as well as how to connect the smart meter, energy meter that needs to be purchased as well. One thing to note with the system, the additional purchase that is required for the ETLV series in paralleling is the GM330 energy meter, as well as the 3 CTs that need to be installed with it. The 3 CTs that need to be installed with it are any 5 amp secondary ratio CTs, so a 100 amp by 5 amp CT, a 300 amp by 5 amp CT. So long as it obviously is a 5 amp secondary ratio CT, it will connect perfectly fine. You'll see small things that you do need to just take note of when running parallel on systems. Most importantly is the dip switches. So if you look, there is the master inverter, the slave inverter. First slave inverter will have the dip switches off, and then the last inverter in the chain all on again. All of this is readily available in the user manual, and we can get all of this from there as well. Battery compatibility. So like all of our inverters or hybrid inverters within our system or within our product range, we have got dedicated compatible battery lists. So we have got 2 battery lists available, one being our Type A battery list and the second one being our Type C battery list. Type A being our international battery brands, Type C being our local battery brands or default setting batteries. With regards to our Type A battery list, so our Type A battery list is all of our international battery brands. That is where we do full-on international battery compatibility testing and line-by-line protocol testing. Meaning Dynas, for example, we will send an inverter to Dynas, Dynas will send a battery to GoodWe, and both R&D centers will match the protocol line by line. When doing the configuration on the system and you set the battery up, or set the communication up for the battery rather, we will select Dynas DO5.0C, and it will then be able to communicate directly with the battery. Other batteries, we will use our default setting. So we have a default 100 amp selection, and we use that for all of our local compatible brands. So batteries like LBSA Lithium Battery South Africa, or Freedom One, or BSL being one of the most popular ones that we see very often here in South Africa. We will then Revolve being another one. We will use the default compatible default 100 amp hour setting when running the configuration. With regards to warranty and our battery systems like this, it doesn't really matter which battery we use, whether it is a Type A international brand or a Type C local brand, the warranty will be held the same way from a GoodWe standpoint. Provided we use a compatible battery, we will offer full support, and if something goes wrong, battery related or not, and the inverter needs to be replaced, we will replace the inverter. As an upsell for our own batteries, we have got our own battery brand, and I'll go into that in the next slide. We have got a warranty upgrade from 5 years to 10 years for both the inverter and the battery. The battery will come with a standard 10-year warranty. The inverter comes with a standard 5-year warranty. If you purchase a GoodWe inverter and add on a GoodWe battery series, the inverter automatically upgrades from 5 years to 10 years. If you purchase a Dynas battery with the GoodWe inverter and you want to upgrade the warranty to 10 years, it is possible to be done. Please contact your distributor when making the sale or making the purchase of the inverter, and we can look at how we can assist you with getting the warranty upgrade done. So the next part of the session is to have a look at our Lynx AG3 14.3 kilowatt hour battery. This will be phased out and replaced by our 16 kilowatt hour battery that will be coming soon. However, right now we have got the 14.3 kilowatt hour battery available. So this is a more enclosed battery. It's not a normal rack mount battery like our 5 kilowatt hour battery. This is a much bigger unit, and we can either have it floor mounted or wall mounted. We have got an intelligent LED display on the front of it with some light diagnosis to tell us exactly what is going on the battery, as well as a built-in circuit breaker on the right-hand side of the battery as well. All of our batteries will only work with the GoodWe inverters. So GoodWe battery works with the GoodWe inverter only. However, the GoodWe inverter can operate on many different batteries. With regards to firmware updates and how we can update these inverters and batteries, our batteries can all be updated. Our batteries can all be updated remotely. We can do it via our online platforms. We can do it via the Sims Plus app. We can do it via SolarGo when we are commissioning the system. Should there be any requirement for an update on any firmware on any of our products, provided the inverter is online, we can do everything remotely. However, we can also do it on site locally. Quick look into some of the technical data on the battery system. So usable energy is 14.3 kilowatt. Nominal energy is 14.3 kilowatt hours. Usable just under 14 kilowatt hours. The nominal voltage at 51.2 volts. Maximum continuous discharge at just under 1 C. And maximum continuous charge is at 0.8 C. So this is an IP20 rated battery. Can be installed on the floor using the feet that are provided. Otherwise, it can be wall mounted with the bracket provided. And we can install this obviously off the floor. It does have quite a hefty weight to it at 125 kgs. So do bear in mind that when doing the installation, use 2 or 3 people, please don't hurt your back. This is some of the product appearance. So the LED light strip on the front of the battery allows us to see exactly what is happening on the inverter, on the battery, without having to go into any logs or anything. We can see exactly what the lights are doing. We can see exactly what is happening on the battery itself. So this battery and all of our other batteries do have black start functionality. So we can black start and start the battery up, start the inverter up directly from the battery. We do not need AC or PV power in order to start up our inverters. Here are obviously a better understanding or better description of the lighting on the inverter itself. Everything from the power button, communication light, system alarm light, what any of them mean, as well as the SOC light or green indication light on the battery SOC itself. So see it's in 4 sections, obviously 0 to 25, 25 to 50, 50 to 75, and 75 to 100%. When the lights are full, means that the battery is full up to that percentage. So if the first 3 lights are full and the 4th light is flashing, means we are discharging the battery between 100% and 75%. When the second light starts flashing, will be between 75% and 50%. When the lights are solid green, the battery is either charging or in obviously a waiting mode or completely full. As mentioned in the parallel slides, the battery does need to be connected to a bus bar. The recommendation is to be connected to a bus bar when paralleling more than one battery. GoodWe have got their own bus bar, which is the BCB32-WW-0. We have got a smaller one, which is a 22. It's just the physical size of the bus bar itself. However, the working power, the maximum goes up to 720 amps, the working power of 36 kilowatts. We can, however, use any third-party bus bar. Again, if we refer back to the user manual will show you how the communication cables need to work. And by changing the communication cables slightly, there are 2 pin layouts or 2 pinouts that need to be terminated. Once those are done, we'll be able to reach that 720 amp working power, higher depending on the solution. So if we parallel the system and we have both battery inputs being used on one battery or one battery stack, we can tell the inverter when commissioning that we are bridging, paralleling the 2 battery inputs, and your BMS cable goes directly into BMS port 1 from the master inverter. The master inverter will then obviously relay all the information and messages onto the 2 slave inverters or rest of the slave inverters, and they will be able to see everything and make sure we get the most out of our batteries to keep the system up and running. That is all for the physical presentation. If there are any questions, please do let me know. With regards to our support contact, so we have got a dedicated local support team. The support team run from level 1 through to level 3 support, obviously all within country. Starting off with our level 1 support contact center, as well as the WhatsApp line, email, and actual ticketing system. The support center, you can call WhatsApp anytime, Monday to Friday between 8 and 5. And if you have any queries on anything, get in contact with them. They can't assist you, they'll put you in contact with the people that can. And to leave this slide up for a few more seconds, and then we will close off on the presentation. Okay, I'm going to just have a look and go through the Q&A section quickly, just make sure if there are any questions, if I have maybe missed them or have not missed them. Okay, there's a question for our contact details from Kampala, Uganda. So if you go onto our website at goodwe.com, you'll be able to find all of our contact details for all of our sales centers, sales and repair centers. I will just have a look quickly for you. So with regards to the contact team for Uganda, if you can just send a message to our support team here locally, we'll be able to share all of that information with you. Alternatively, you can reach out to anybody in the team and they'll be able to get that information through to you. The presentation has been recorded as well, so that will be uploaded to our YouTube channel, as well as to everybody that attended the session today. So look at our teams in Kenya, Mozambique, as well as for Uganda. So that gets serviced out of our Kenyan team, and you're welcome to get into contact with anybody there. Perfect. Thank you everybody for joining today. Really do appreciate it. If there are any other questions, like I mentioned, get in contact with us. Let us know if you need any other information, and we'll be sure to assist you there. Thank you very much. Have a wonderful day further. Bye-bye.